please welcome Will Pearce.
Hey. Can you get... Already coughing. Can you guys hear me okay? Yes. Cool. Well, welcome to my talk. This is technically my first talk that I've given. And skimming with machines, we're going to talk about the offensive use cases of machine learning. We're not going to talk adversarial machine learning. And we're going to talk about using ML to support offensive teams. So, who am I? I'm Will Pearce. I work for Silent Break Security. We're a small security consulting firm in Lehi, Utah. We're kind of known for custom malware dev. We write all our own malware. We teach 2 courses at Black Hat, Dark Setups 1 and Dark Setups 2. They both focus on malware dev, and Dark Setup 2 focuses on research. Has anyone taken the Dark Setups courses, out of curiosity? No? So we just got 2 days of training. So if my voice goes, I'm sorry. But my primary function is I'm an operator. So I fish people, I write reports. My job is effectively to breach organizations, write a report, tell them how I did it. I'm not data scientist. The second piece of my work is obviously research. So this is the research piece for the last year, 18 months that I've been putting on. There's a lot of excitement around ML. And actually I have kind of a finance background. So can anyone use Excel without a mouse in here? Is there any keyboard monkeys? Yeah. So that's my claim to fame, is I can use Excel without a mouse. If you're ever at a very boring party, that's my party trick. And then we do obviously teach training. So we teach Dark Setups 1 and 2, and we write training and things like that. So our agenda for today is we're just going to talk generally about ML and InfoSec, and it's going to be from my perspective as an operator. So whatever that means for the products that we see, the hype that we see, and what I actually see on networks versus what maybe vendors are claiming may or may not be true. I'm also going to talk offensive tooling. So I have 3 case studies that we're going to go through that I've sort of developed. If you're here for any groundbreaking ML research, you're not going to find it. But what you will find, I think, is some interesting use cases from a very lay person's view. At least someone who's trying to harness ML to become more efficient. So, as we know, vendors, old dogs, new tricks. From my research, what I know is ML is not magic, it's math. So no matter what anybody tells you, how many in here are MLers, like data scientists? How many red teamers, pen testers, blue teamers? Cool, so it's a good even mix. So we all know it's math, not magic. I think a lot of the products aren't quite built yet, and the marketing engine is going. And so we're starting to look at it more critically. It has huge implications for the red side, just in terms of the sheer detection capabilities and the sheer amount of data it can go through. So it's extremely important, I think, for offensive teams to at least take a look at it. My current thought is that maybe machine learning might go the way of app whitelisting. So if you remember a few years ago, everyone was like, oh wait, you can just block PowerShell.exe and no one can run it. And then the Lolblins project came out, and they're like, oh, as it turns out, there's just a ton of stuff that can execute things. So it's going to be interesting to see how vendors try and implement they just have an impossible task of just an enormous amount of data. So it's interesting to listen to these talks. So vendor claims are generally overblown. The data requirements, so in organizations that we get into or we consult with, most of them have insufficient logging and alerting. So as we know, ML requires some amount of data, some amount of consistent data. Obviously, there are techniques that I'm not aware of or can't speak intelligently to fill in data sets, but I do know that ML requires data, and I know that organizations don't always have the logging required. ML also is a significant engineering challenge, so there's just a ton more moving parts. There's models to keep updated, there's model drift, there's any number of, and they still suffer from the same problems that current SIMs suffer from. So false positives, poor system implementation, open shares on the network. So if you're keeping your model in an open share, we could steal it. So a lot of times what we do is we'll actually find, code or products written in .NET, which we can then pretty easily reverse because it's not a compiled language. And it's the same for models. So I think the first neural network I found on Network is a business app, and it was legitimately in an open share. So that model was just there for me to take. And if you know anything about adversarial machine learning, that opens the door to any number of things. And then we get to data scientists running the sim. So what ends up happening is, it becomes very expensive to run, have a full-time employee to run your SOC or your sim or monitor alerts. So what ended up happening is people went SOC as a service. And what I know as an operator is SOC as a service is terrible because it's just an average of everything. So you're just a client. They don't necessarily, they have an SLA with you. So, probably the best one we've come up against, it was 24 hours later, our client got the call from the SOC, and it was too late. So if you're going to have data scientists running your sim, you're going to have a bad time. And we've seen it before. But if you look at the tutorials that are kind of out there, so I like Babies First because it's the tutorial is the DEF CON thing. So from a malware perspective, from our perspective, so the red side, so I see all these tutorials like, we can detect malware, we have all these PE files, they're all statically in this folder, we can read in all the bytes. Well, we primarily, modern execution happens in memory. So you're not going to be able to gather enough. Well, you can gather samples and you can view them, in memory, but just a static PE file, I think, is going to fall short of a detection in a real environment. Phishing. So I think Proofpoint is a great example of this. Proofpoint has a pretty good product, but it ignores vectors like LinkedIn or Twitter. So instead of just going through a difficult, ML-enabled mail system, I'm just going to, hit you up on Twitter with a document or hit you up on LinkedIn with a document. So then I'm pushing the malware from the mail filter to the web gateway, and mail filters aren't going to catch it. And this is something we already do because of increased detections. And then on the network, so we see we can detect DNS traffic with machine learning. It's like, well, if you have a pair of eyes, you can detect malicious DNS traffic. Malicious DNS traffic looks extremely malicious. So when you're trying to shove as much data into a DNS packet as you possibly can to get your, that transfer back and forth, you don't need machine learning to do it, and you might be introducing additional complexity that's just unnecessary. So you're going from something that's certain to something that's less certain, or something that generalizes versus something is true. But from our side, so what we see is typically from the route, so sequence analysis of function calls. So there's a paper out by two guys, or a couple of guys out of Sandia, and they wrote a paper about detecting malware using the 32 API calls. So for me, if we're living in memory and we rely on those API calls, that's something we should pay attention to from my side. From phishing, so we have a much harder time phishing than we used to. We used to be able to send 5 or 6 emails, get up maybe 50% clicks and shells. But now we're just seeing context-aware spam filtering, so it's just much more intelligent. Anything with a link is getting picked up. Anything with a link is getting visited and pulling down those payloads. So it's just an additional headache that I think our side of the industry is still kind of reeling with. But obviously with things like going to LinkedIn, it kind of makes it a little easier. But we're just having to spread it out versus only email. And then on the network, we need information to perform our jobs, and so that requires querying any number of services or servers. And if we're on a host, Jim in HR, and we're querying some SMB server over in the accounting department, even if you don't have host isolation, that's going to look anomalous. Like, Jim shouldn't be doing that. So if you have those detections in place, but at the same time, you could implement a machine learning model to detect it, or you could implement host isolation And in that case, just the traffic doesn't exist anyway. So, it's obviously give and take. So, our perspective, or at least my perspective, of ML, at least in the short term, I think offensive teams actually benefit in the short term. So, our data sets are smaller, our expectations are lower, because let's be honest, none of my team expect like anything useful to come out of ML. But that's on them, because it does work sometimes. But effectively, we want to. My job is to try and augment decision makers. I want to bring information to them so that they can make the decisions that they need to. And then, as I slowly, pick away at that, eventually, I would like to get to a point where we have some semi-intelligent operation going on. And just generally from the red side, like we need to be able to create better tools. So later on in the presentation, I'll talk about pushing models client side. So if we could ship malware with ML models in it and just never have comms, that'd be awesome. Or if it could do, rather than reaching out to communicate, on an external domain, if it could just collect information on the internal network and just shovel it back out whenever we need it to. It's going to be preferential. So if we can trust it on the internal network, not to destroy anything, then it's going to be preferential for us. And ultimately, we just want to be better operators. So every operator has like 10 commands they run. And if I could get to command 5, and rather than going through my normal 6 through 10, I can just go straight to 10 because of some information I got in the previous commands, then that makes me a better operator and just more efficient at my job. So, I actually wrestled with this title. I said new kid on the block, and it's not technically true. But it's a new kid on our block, especially from the offensive side. There's not a lot of research out there. There's some pretty sweet projects, and actually if you go way back, there's some really cool projects. But I just want to separate ourselves from adversarial ML. So adversarial ML, it's obviously like, let's make this model think this dog is a cat, or classification bypasses. It's more than that, but basically we only care about classification bypasses because we're cavemen. But I want to talk about offensive ML and just that using ML to support offensive operations. So some awesome research. So the parsec, the timing attacks, deep exploit, the big language model. They said they didn't release their big model, but we found like the smaller models are just as good at generating phishing emails. It's Markov obfuscate. C2 is pretty awesome. Basically just obfuscates using Markov models through, and you can C2 over it. It's pretty crazy. Mapper. This one was, DEF CON last year ago. But it's coming out. Deep word bug. This is awesome. But I have kind of started to aggregate these projects at my GitHub, which I'll post a link to. But it's just redm. So I'm starting to collect these projects to start aggregating them. But when we're talking ML, so we have, I think, a unique set of challenges on our side. So our data sets are very sparse. We might have like 30 projects in the pipeline, each with 5,000 lines long. So we just, by traditional ML standards, we just don't have the data to do things. So my epochs are higher than they need to be. Overfitting is, in my view, for us, not a problem. Just because our use cases are much more focused. We're not necessarily trying to generalize. We actually might be trying to be very specific. So in that way, I think of sort of overfitting as a tolerance. If you imagine like an engineering term. So how close to that tolerance do we want to get? Again, I don't know if I have a professor liaison who's been helping me. And it basically means go like, hey, I think this is possible. She's like, yeah, I think that might be possible. I'm like, okay, sweet. So should I go and do it? She's like, yeah, go try it, see what happens. Transferability. So we are in a lot of different networks. So we obviously can't store data for the purposes of other networks. And a lot of that data is very sensitive. So social security numbers, KRB, TGT hashes. We just can't keep it for the sake of machine learning. So we have to find a way to make our models both useful, but also agnostic to each network. So I think it's potentially a unique challenge. And then sharing data. So as offensive ML becomes a thing, we can't share data like we can share other TTPs. So I can tell you like, oh, you should go look at install util because you're going to be able to get execution, application whitelisting. I can't give you a data set because it might contain some KRB, TGT, or if you have enough domain knowledge, you might be able to reverse it and get something if you're clever enough. And that potentially could just come from my lack of understanding of. But there's a book, it's called Adversarial Machine Learning. It's blue cover, and it's pretty great. Oops. Cool. So when I start to think about the problems that we kind of face, or the ones that I want to solve, I don't think ML is on the blue side is speeding up, so that just people are just behind it, and so I think unless we, the red side, start looking at it, we're going to be left behind. So it's a bit like the frog in boiling water before it dies before it realizes it's too hot. So my hope in this is if you are red teamers to start looking at it because it is useful. Beyond the offensive ML, organizations are going to be implementing it, so you're going to need to have some basic understanding of it if you're going to want to operate in networks in the future, assuming it takes off. But as I go through thinking about solving a problem, I have this empirical analysis, so I have experience as an operator that leads me to conclusions. So I know what an expected output should be for a given input. That's kind of what I do as a human. I have my own anecdotes as well. So I have my own anecdotes. But those could be slightly skewed. So in one network, I might have been able to do something, and in another network, I might have done the same thing and it not work, and I might assign the fact that it didn't work to something incorrect. So from then on, going in the future, I'm going to have some false assumption about why it didn't work until that is corrected. And that's going to come through in my ops. And then there's statistical analysis. So, how many commands did I run? What was the length of my commands? That kind of thing. And I think the blended approach is really useful. We'll get into some statistics later. But the first case study that we're going to look at is classifying a sandbox. So I don't know if I had a blog out a while ago, it was almost a year now, and I said part 1. And I was like, if I put part 1, I'm going to have to put part 2. And I didn't, and this is part 2. This is what you're looking at. This is the talk. So hopefully there'll be an update, be part 2 through 7, I think. So playing the sandbox. So, part of our job is to package up Word macro, Excel, whatever it is, and try and get some user to click on it so we can get execution. And part of that is obviously basically any email with an attachment these days is getting executed in a sandbox. And sandboxes are kind of outsourced analysts in a way, and their job is effectively to make some determination about the safety of that payload. And it's been traditional, like, okay, let's change the strings in it, let's link it instead of attach it, just to try and get it past the mail filter. But they're kind of dumb machines, and they're very automated, and they don't do, I wouldn't say they do a great job, and they're very easy to see as a human. So I think playtime is over. So why would we care about being in a sandbox? Well, we write our own malware. So that represents a significant portion of IP. So if that piece of malware gets compromised, that represents a significant amount of time that we're going to have to spend rewriting that piece of malware. I mean, Slingshot is our main tool, and we've probably been deving on it for 7 years. So it's not like, and actually we don't send in Slingshot for that reason. We have a stage 1 tool that does that. So we have a smaller piece of malware that is responsible. But we just want to protect our payloads. We just don't want to give it away for free. We don't want to be spraying the internet. We don't want to be accidentally detonating it in someone's personal account. So we need to make sure that we protect our payloads even from sandboxes. Alert fatigue. I saw some of you raise your hand for blue side. You guys are obviously familiar with alert fatigue, right? But little known fact, so are we. So we put image pingbacks in our macros. So there's an insert field code, and once you open the document, it'll go down to a remote web server, and it'll try and pull down an image. We just put an arbitrary URL, and it has a webhook, so when it hits it, we just get a text. Well, it's all well and good with, you open your email and we just get one. It's like, oh sweet, got a shell. Or I got someone to open it. But in Sandbox world, they like to share it. So it's like you get one, and then you get two, and then you get 5 and 20. And so I don't want to be up at 3 a.m. responding to Sandbox alerts. So if I can push that job to ML and just be like, you deal with it from the hours of, even from 6 to 6 overnight, then that's worth research for me because I get more sleep. It's pretty easy to detect a sandbox. So does anyone have experience with sandboxes? Much? Did anyone look at the process lists of them? So if you look at your process list on a sandbox or just a host that you don't use very much, even a Windows 7 VM versus a user's box, there's going to be a very clear difference. And I'd say human operators like our team can detect a sandbox probably 99.9% of the time. But it gets laborious to do. And so we want to make sure that we just want to break it down. So we get a process list back for OPSEC purposes. So we use a stage 1 tool. We get a process list back, and it's kind of a look before you leap. So if we, in the process list, see like silences on the box, for us that means a handful of commands are off the table. So before we're even interacting with the target, we have some expectation of what commands that we can run versus not. So we're not going to be on the host generating unnecessary alerts just for the sake of not having had a process list to begin with. So I guess that's why we are even looking at this process list to begin with. So there are clear differences. The other difference, obviously, users are going to have like Chrome and Word and Excel. Sandboxes aren't going to have any of that. It's just going to be very basic. Typically, the payloads get run as admin. It's Windows 7, VM. So they just look very different. And this chart up here is just a little PCA thing that I did. So it's obviously the classification piece. But by the numbers, so if we're looking to select features, I chose process count, user count, and then a process user count ratio. Admittedly, they're terrible features, and obviously a label. But it illustrates the fact of you don't have to use any NLP to sort of break down the numbers. You can just use features. You can use the pure process count, the user count, any number of ratios. It doesn't have to be this really complicated thing. It's just data representations. It's like however you want to represent that. And obviously I know there are techniques to pull out the best features, but for our purposes, this has worked, pretty well. And it's you're not just limited to the features. So if a lot of people have their own checks that they want to make. Process list is ours, but some people like recently used files. Is a keyboard enabled? What version is it? Is there a username attached to it? So sandboxes often have like Bob. So the one admin John, admin PC. So they just don't try very hard. But you can just you can arbitrarily just attach whatever you want, and these kind of become representations of your sandbox, your data set. And if any MLers, if I say anything incorrect, just talk to me afterwards and correct me. That would be actually extremely appreciated. So if we're looking at decision trees, this is sort of the first, actually this was the second model we went to, because obviously when you learn ML, you're like, I want to do the cool stuff. So what we did is we actually went to neural networks first, and then we're like, okay, this is all right. And then we went back to decision trees, like, okay, this is actually way better because it's simpler. I can explain it to my operators, so I can be like, hey, you didn't lose your shell because I don't know. You lost it because, I can explain it to them. And I like to think of it as 20 questions for an algorithm. So it's easy to explain to operators who I've already mentioned are a bit like cavemen. But you guys are familiar. So effectively, you just have a root node, and then it's making some determination, and it's going to, true or false. It's going to just go down the tree until you get to some conclusion of the classification. piece for it. And the code's super simple. So even if you're not mathematical, like I'm admittedly pretty terrible at math, as long as you understand the concepts and the code, and you kind of understand what goes in and what comes out, and on balance you can get it. It's extremely accessible. So it's not. I wouldn't say it's not like math that you did in high school where you're solving problems. I would say maybe not fallen in love with math again, because I never was necessarily in love with math, but just the fact that it's more about concepts and expressing ideas in mathematical notation. So it's kind of cool. So you don't have to be mathematical to implement these things. You can do it as long as you obviously if you want to get into the details, you'll have to know, but some simple stuff. So then obviously neural network. So we have our inputs, we get our output. They're the weights. So the stronger the weight, the stronger the signal on the output. So we just make a prediction on it. So it's kind of basic ML stuff. I'm going to shy away from explaining the models because I know there's some ML in here. And if you want to Google, I'll just do myself a disservice if I try and explain it in front of professors. So I'll shy away from it and I'll talk to the operations piece. But again, this is the code for it, and it's super simple. There are libraries like I love Keras, and it's just you have a couple backends on it. I've been moving more into the PyTorch area just because it seems to be more academic and maybe a little more supported. And then also ML.net for client-side ML. So Windows just actually said they use ML.net in their Windows Defender product. And so it's going to be supported for the foreseeable future. So it'd be awesome to be able to use ML.net in your malware and ship it client-side. It's the same thing Microsoft uses. It's going to be supported. I don't see why you shouldn't or couldn't. We have some Microsoft people in here. So the code's super simple. And so we have the models once we've built them. So I have a server that I'll release. I called it Deep Drop. And effectively all it does, it has these two models trained. And then we have a function. So there's a macro with it. And all it does is it posts back a process list as we would. And then effectively you just parse the process list as you would a regular. Instead of doing a lot of them, you're just doing one of them. You'll gather your features. And then you'll make a prediction on those features. So if you're in a neural network, obviously you're going to have to scale them to whatever is appropriate. And then after that, we're going to make some sort of, if the prediction is good, we're going to drop our malware, otherwise we're not. It's very simple. So it would be tantamount to be like if you had another singular check that you were just shipping off. This is very basic dropper code here. So there's always going to be some dropper decision. And you could also push it client-side. But it's not all nice. So you have model drift. So overnight, all of the sandboxes could change. So they could all just be like, we're done with Windows 7, we're going to go to Windows 10. And then that's just having looked at it. The Windows 10 process list is much larger and already much closer to a regular user host. So once we start getting, for example, a stock Windows 10, our model gets a little fuzzy. It gets hard to it's harder to determine. Network defenses, so obviously we've noticed a few vendors, their sandboxes have stopped reaching out to the internet. So if we don't have information, we can't build models. So we kind of need that feedback. And then data collection for phishing campaigns. You're going to need a separate process. So you can't collect data while you're phishing. So those two pieces of code need to be separate. So in a production like fish or a production macro, you want to keep it small, you want to keep it tidy, you want to keep it as small as possible. But when you're just collecting data, that adds code weight to it. So you need a secondary effort. So you're going to need some sort of secondary phishing campaign that, it could quite easily be automated, where you're just going out and just sending things to VirusTotal or clients. And anywhere you can get execution in a sandbox. And that'd be separate. So that's going to feed your model, and then your prod VBA or your prod macros are then going to rely on that model to make some sort of determination. And adversarial inputs. So we've kind of come a little full circle here. So if we were to post back, if we were to make like those the features post back in a URL parameter. So for example, in a GET request, and parse those out. Some clever analysts could change those inputs fairly arbitrarily and get trick our deep drop to deploy our malware and get it out. So for example, if we were to just that top line there. So if we were to send this in a URL, we're going to get someone could arbitrarily intercept it and change those numbers and then force our dropper to do it. So there's going to be some check on the other side, and what's funny is like I'm dealing with the same problems now that the blue side is dealing with. So it's like it's kind of two sides of the same coin. Let's see. So the other thing I mentioned is client-side models. Like Excel is built for data. So you can build a neural network in Excel. You can build a decision tree in Excel. So you can then package up your model, send it with Excel, and it's as if you have sent some sort of operator intelligence with it. So it just never has to reach out to the internet, and it has everything it needs client side to make a decision about whether or not it's safe. This is kind of awesome. There are some caveats, so I haven't heard of anyone doing this, so your macro is going to stick out like a sore thumb. And you lose the ability to troubleshoot. So in our macros, I mentioned the pingback, so we know when a document's been opened. We have a macro pingback, so we get a process list back, so we know when the macro has been executed. But if you push it client side and you never get anything back, you can't troubleshoot. So let's say, for example, we get that macro pingback, we see a process list. We can be like, oh, but this product's on the box, we'll just try a different payload. But if we never get that process list back, we can't make any assumptions about what's on the box or even anything that happened. So it's like, it costs you something, effectively. So it's going to cost you something to send it client side, and we kind of need that information to make intelligent decisions on our side about the future of our op. So let's see. So now I have a demo of it. We'll see how this goes. You guys can't see that, huh? Okay, so obviously we have this terrible output from wherever back here. Okay, so this is just deep drop. I'll release it on GitHub, and it's super simple. If you guys have questions or whatever, so it has 2 pre-trained models. I'll release a data set with it as well. It has like maybe 200 things. I can't release like full process lists because I have client information in it. So you'll get the just the features that I've selected. So just starting it, super simple. It's just going to load your models, and then I have a macro that I'll release with it as well. So here we load our neural networks. We load our routes. It's just a Flask implementation, super simple. Then I have a macro that I run, and then in the background it'll run that. So we're not going to drop the payload. So I have it on a little VM just running in my lab. So it's super simple. Like it's really not that difficult. Like you guys probably do much cooler stuff between the hours of 6 and 8 than deep drop. Any questions about that one? Fairly simple. Again, if you're here for breaking ML stuff, you're not going to find it. But this is kind of how we're thinking about implementing ML on the offensive side. So command recommendations. This is our case study 2. So we went from this really easy, awesome thing to something that's actually extremely complicated. So when I first got into it, I was like, oh, what would be sweet? Command recommendations. That would be awesome, because then I would just have any command I could just ask it, and it's just going to tell me, and I don't have to think anymore. But that's not how it turned out, obviously. So old habit. So we have existing knowledge that we want to take advantage of. So I have a model in my brain that's like, I need to run these 10 commands, and based on this information, I'm going to do this other stuff. So we want to take advantage of that. So we have a team of 6, 7 operators So I have logs for all of them. So we have parsing for all of it. So I get just everything. So I can see, kind of everybody's session logs for good or for bad. Some of them are pretty dirty. Not in terms of dirty, but they're just like, their OPSEC's terrible sometimes. So sequences of commands, like we know there are models that can analyze sequences and give us probabilities. So, we can say, based on all these logs, based on all these commands run, based on this sequence of these first 10 commands, the 11th command is probably going to be X or LS, dir, whatever it is. But what's more interesting, actually, is when you look at this is where we get into the statistical side, is you can start to see patterns in an op. So once we get initial access, there's like a grouping of commands that we initially get. And then as the op progresses, like when we're privileged, then there's a different set of commands. And so it's been really interesting to see sort of even though we know it and we do it, it's been interesting to see those subtle hints of transition throughout an op. So these are just a few ops that I pulled, and it's just a simple graph, but effectively number of commands, and each color represents a different command. And so we get a pretty colorful distribution, but obviously orange, and I think this is our PowerShell. We have an in-memory PowerShell that we run. I think this is our PowerShell, and then the other one is getUID. But so this is some basic metrics from our ops. So it's for the last rolling 12 months. And obviously we don't keep data around, so some are deleted, or some just aren't useful anymore. But 6 of us, we ran almost 60,000 commands among us across 30 ops, and we averaged almost 2,000 commands. So aside from just the ML stuff, like looking at this data from an operations standpoint is extremely useful. So how long do you think it takes you to type a command? 2 seconds, a second, half second? Well, okay, so now you can multiply this by 2K and you get some reasonable assumption of amount of time that you're going to spend on an op. So our project manager loves this. I haven't told him about it though, so don't tell him. We have 99 possible commands in our RAT. We ran only 84 of them. So from a malware dev standpoint or from an OPSEC standpoint, we could probably drop 10 commands and we just lose all that code, and then our binary is smaller. So not only does it, this kind of analysis help us shore up our ops, but it helps us find bugs in code faster. It helps us find where operators are having issues faster, and it helps us to just remove unnecessary things that just get built into products. If you think of your malware as just another piece of software, this kind of analysis can be extremely useful. But then you also get stats like, the most commands is obviously an outlier, and I know which client that was, or the fewest commands where somebody started it up and just exited it really quickly and nothing useful was actually done. Or the longest command where someone's uploaded a DLL and that command just gets, that DLL or shellcode just gets put in their log. And so it's not necessarily pretty, but I think going through this process, it helps you take that next step towards ML. So it helps you think about your data, helps you think about structuring it, helps you think about, so I think it's an excellent first step toward some sort of offensive ML. And I don't think enough red teams spend enough time inside their data. So these are our top commands. So if you look at the total here, these 15 commands are almost 90% of everything we run. But I already said we have 99 commands. So it's like, what, right? So we could probably cut 50% of our commands and not notice a difference in ops. And that has a significant impact on our detection rate, potentially, on the number of APIs, the code that gets loaded into memory. So it's extremely, extremely beneficial. This PowerShell, so PowerShell is obviously a bit of an interesting one because it's just a wrapper for other commands, effectively. And of the PowerShell commands, I think 85% of it was get domain user, getnet local group, and get domain computer, and then some variation of those. And then there's like some other ones. So it has been actually pretty enlightening to go through this. But getting to the data is extremely painful. Like parsing is really difficult. So currently, I've written a database, but it's not in our product. So we have logs. So I have to go through unstructured text. Our regex is like 80 characters. Took me a ridiculously long time. But to get to the data, you have to extract the commands. You have to somehow deal with the arguments, which I have not figured out yet. So you'll see in the demo. So the arguments is just impossible. So there's like 6 ways you can run get domain user. And you could write regexes for everything, but if you have 99 commands, like that is a significant amount of work. So I have to think about, is it really worth the effort? Or maybe you guys can tell me, does NLP like have an answer to this? No, no, it's regex, right? That's the problem. But once we have it all, we can start to model the user, and we can start to build out maybe particular profiles or whatever it was. But we talked a little bit about sequence analysis. So based on the previous sequence of commands, we're just going to get some sort of distribution, some sort of probability of the next command, and then we're going to run that one. So recurrent neural networks, and then long-term, short-term memory. And this is the one I'm not going to explain. So you guys can go Google these. But what I do know is that there's input, there's a sequence, and then there's some distribution, some probability that gets put out on the other side that gives me the next command based on the previous sequence of the analysis of the previous. So, demo. The project I found was actually, it's just TextGen RNN. So it has an interactive mode. It seems pretty clean. Well, I shouldn't say it's decent. But here we're loading all of our GPUs. That has an interactive mode, so it gives us, let's see. So here you can see like it just builds it just goes one by one. And then, so if you think of getUID, so getUID is to get the user on the box. And that's usually one of the first commands we run if we don't know. If it's not, it's PS. So you can see after getUID, it gives us options. So these are the next 10 commands that most of the time run. I think we run into issues because we only have 99 commands. So there's only 99 possibilities. And so if we don't, for example, don't train enough, you'll get that where it'll go, pshell, getUID, pshell, getUID, pshell, getUID, and it just doesn't go anywhere else. So that's been somewhat painful to deal with, but actually not as painful as the arguments. But it's a start. I wish this would go away. Do you guys have any favorite projects like for RNNs or LTSMs?
How do you deal with compound commands?
I haven't yet. That was the challenge, yeah.
So that's one other question you can talk about the regex.
Yeah.
So the shell actually parses the command.
Yeah.
It is.
Mm-hmm.
So can't you just look at what's expected from the shell and say, oh, this is the command?
Right, yeah. So you could do that, but we have our own shell. So we use the CMD2 library. So that's actually my next stop, is to look at their parser and see how it does it. We have some modifications there. But effectively, I just need to dig deeper into it. I was hoping there'd be a more elegant solution than regex, but that's where I'm at currently. But this is kind of where we kind of started at a high with, it was very easy to implement some binary classification, but it's very quickly, it devolves into this very challenging, not finicky, but very quickly it devolves into this very architected solution where you need to have multiple data sets and regexes that you're keeping offline. And so suddenly someone like me who is interested in ML but is primarily an operator, if I think about my teammates, they just don't have the patience for it. But if it's almost like if they don't learn the basics of ML in 3 years, they're not going to be able to op on a network. So depending on the adoption rate of ML in networks, I think this talk, hopefully, if red teamers, obviously you're here because you're interested in it, but hopefully you get the idea is like you need to start looking at it. You need to start thinking about your commands. You need to start thinking about the processes you inject into. You need to start thinking about the sequences of commands. You need to start thinking about how the sequences of the APIs that your commands call. Like inject arbitrary APIs, just like between virtual, create remote thread or virtual alloc, just put a ton of different APIs. So it's like, I don't know, Microsoft has put in like these monotonic models that supposedly, I'm not clear on the details, but what I've heard is that they prevent you from adding good features to, so then we're just back to where we started, where we're just removing malicious features, or we're trying to doppelgang like explorer.exe. So it almost feels like AV is starting over. It almost feels like the traditional AV is like standing still, and we're just in this run-up phase until people have figured ML out on the defensive side. But what I think is going to happen is that my experience has been it's not as easy. It's not as easy as it seems, and there's a lot of nuances to data, and you guys already know this, but there's a lot of nuances to it that at scale become almost impossible. Like I do not envy anybody who's trying to solve that challenge. And actually I wish I had saved that tweet. There's a guy, I forget what his name, but effectively I think he worked at some AV vendor, and he's like, I've been doing this for 6 years. And the best thing we've come up with is network alerts. So if that tells me anything, it means like that's the data that you have. Like companies paid vendors to like take in all their logs, and vendors just threw it in a pile. Like there's no structure to it. And I think now they're realizing their mistake, and they're having to go back through and like structure it properly. But I still don't know how they're gonna deliver a consistent product when all of their clients have different levels of logging. So do you have models for different clients? Do you aggregate everything? What do you do? I think probably the only person, or the only company who probably gets away with it is Microsoft, and that's just because they're scale and they're on the OS. But if you think about like the AMSI stuff, and where AV vendors can have hooks into AMSI, even that provides you limited, like the Silence research. Do you guys see that one where they had that silence bypass? I put it in air quotes because you're still not going to get that past AV. Silence did that as a way to sort of backdoor their model, because it is even legitimate EDRs now have a really, really difficult time deciding what is legitimate execution and what isn't. So if you're living in Explorer, you can basically do what you want, because Explorer is an extremely noisy process. But if you take that away and you put it in an ML model, it just becomes, I don't know how, like impossible. No, it doesn't, it's impossible. There's super smart people. But it just becomes an additional challenge that you're gonna have to solve. And I don't think, we're just gonna, I kind of feel like we're gonna be in the same place 5 years from now. Okay. So the challenge is obviously arguments, and then assuming a human expert. Oh, sorry, thank you. Sorry, some panic from the back there. Assuming a human expert. So, when I'm on an op and there's something not working, I have to troubleshoot it, and that's going to increase my command count. It's going to increase, it's going to put those sequences off. So implicitly, I'm just going to have bad data in my data set. So there could be a sequence at which I get into where the model's telling me to like troubleshoot something, but it doesn't know any better. So it's kind of difficult. So you get just dumb commands or fat fingers, misspellings. It's all the classic NLP stuff. But as I was doing my research, there's some actually really, really old papers from like the 80s and the 90s. As Windows researchers, we really love like subsystems, and like actually one of my prized possessions is a COM book that the Microsoft library sent me that I bought for $3 off Amazon. And COM is so old that Microsoft is getting rid of it in their library. Anyway, so you can go, predicting Unix command lines, and in this paper they basically say, turns out it's really difficult, and there's no conclusion to it, and so, but it's obviously not a new problem, and so that's, I felt better about myself when I read that paper. I was like, oh, cool. No, they couldn't figure it out either. Okay, so now we're getting to the last case study, and it's the reinforcement learning piece. It's a reinforcement learning piece, and this is like the golden goose. This is like what everyone wants right now. It's like this auto hack, all these adversary simulation products that bring in that MITRE attack framework. They're all trying to build like some sort of intelligence into it, and they're just having a really difficult time. It's actually really interesting to see like how different organizations are dealing with it. So like I think the MITRE guys, they use like pre-conditions and post-conditions and things like that. And we're not different, so I'm not different. That's what effectively I'm trying to do. My solution is probably to like step a little further back and start with something a little more simple. But it's like cotton candy. So it's like reinforcement learning could be extremely, on the surface, really awesome. But when you kind of dig down into its basic tenets, it's actually not that useful for us. So for example, we can't have an agent learn a network. We need it to learn real time. Like we don't have the luxury of it being able to go out and fill its Q table with all the right values and then go out and be like, oh, this is where all the numbers are. It's like, yeah, no, we don't have that luxury. But if you're not familiar with Q learning, effectively for a given action in a given state, the environment is going to return a new state and a reward, and it's going to fill out its Q table. There are other methods of machine reinforcement learning, but this is the one that I kind of started with. So we kind of have this state action table here, and if you're not familiar, an LS against the $C on Windows, if you're an administrator, you'll get a directory listing back. If you're not, you'll get access denied. So this is kind of a good check for admin. But effectively, we have this state, so you're an admin on host 1, you're an admin on host 2. We have target network, so we're going to have some action. We're going to LS from our malware into the target network, some host in that network. It's going to return some output. Either we're going to get a directory listing or we're not. And then we're just going to give it some reward, just like that. It's obviously not optimal for a number of reasons, primarily of which we can't learn. We need to learn on the fly. We don't have the luxury of going back. And then the video got deleted for this one, but effectively, so we have running dir. So this is simulating just a false, no directory listing. And then we get, previously we had, actually, you know what? I'm going to live life on the edge a little bit. Cool. Okay, so this is actually our tools thing shot. It's like my little dev environment. We have a scripting engine. So I just have a little script that it just initializes. So we could do, let's say, probably don't have time for 100. Let's not live life that on the edge. Let's do 20. All right, so this is just a bot. We're going to create the network. These are just hard-coded effectively. It's doing something right now. So it's going to go just run through these commands. It's going to start scoring them, and then look at them. So there we go. We got a process list, a directory output. It's going to continue to go. So as it's going, it's just updating the scores, and then at the end, because we don't have a ton of time. Oh, there we go. So there we go. We have it tells you the step, step 0 obviously because that's our local host. So, it's fairly simple. But again, we don't have that luxury. So my solution so far, lost my mouse. My solution so far has been to use fuzzy logic and fuzzy strings. So when I have creds, let's say I have creds to a SQL admin account. Where might that account be an admin? Any guesses? Heard it. SQL Server? Yeah, exactly. So actually, I have a slide later, but the professor that I kind of interact with, she was like, hey, have you tried this? It's Levenstein distance. It's just an edit string metrics. And I was like, This is perfect. Like, this is exactly how I go about. If I have creds, like I've password sprayed, I have creds is exactly, I'm like, okay, I'm like a SQL admin, these are SQL servers, and that's just, and it's not a guarantee that they're local admin. It's just, it's a more likely that they're going to be, you know, local admin on a SQL server than they are like a SIM server, just due to the fact that human nature needs to they label things as such. So that's what we do. So, and if you look at like the degrees of truth thing, like we operate in degrees of truth. Like networks are known, they're unknown, but they're discrete. So it's like we don't know what's in there, but we know they're not infinite. So, you know, we have to kind of go through and play with it. But effectively, we just have these scores, and they're different across the board for each network. But then this kind of feeds into our Q-learning algorithm. But it's, you know, degrees of truth, and I love that. And then the string metrics piece. Levenstein distance has been awesome. So what we do is we collect the network information. We run the fuzzy string networks on a combo of users and hosts. So I pull down users and hosts, and just side by side. And then I select the next action based on a string metric score. And it's just like how I do it. So two things. You've got to be, if you're going to put some sort of AI in a network, my two caveats have been, it has to be better than random. In a default implementation of an RL, action selection is random. We can't have that. So it needs to be better than random, and it needs to be better than an if statement. So if you can satisfy those two, so if you're just starting at host 1 and going down, so if you can satisfy those two, you have a chance at it being more efficient or as efficient as an operator. So I did do the demo. But there are some challenges. Like I said, networks are unknown, but they are discrete, so it's pretty awesome. But cheater, pumpkin eater, you know, pre-filling your Q table, I don't know if that's an ML faux pas yet. So I don't know if you can pre-fill it with memories or whatever that is. But you know, this has been my current solution, and this has been probably one of my more successful. Actually, this has been my most successful, other than the process list stuff. This one has got me, you know, DA every time. So I usually have like a threshold of like 15, and then I'll just start at 1, and I'll go down, you know, getnet local group all the way down, and you know, at least one of them will be. I've yet to convince my colleagues that this works yet, though, so their loss. So that's it. So I just want to say a big thank you to Nancy Fuller of BYU, Brigham Young. She's the one that put me on to Levenstein distance, and she's just been really helpful guiding my efforts. So a big thank you to her. And obviously my colleagues, Nick, as well, for reviewing my terrible code. And that's it. Thank you for coming.